Hello YouTube, De-bodgery here. Welcome to EV Components Review. On the bench is a Votol EM-150 controller. This was sent to me by Mike of evperformance.nl. He's in the Netherlands. He saw my videos on the KO Pro teardown and contacted me on Facebook and said, I want to send you something that you won't expect. And he said, I sell a lot of Votol controllers. I've taken one apart, and I think they're pretty good, and I think you will too. And he goes, I'd like you to do a teardown on one, and so I want to send one to you. So I paid for shipping, and he paid for the controller. So anyway, thanks Mike from evperformance.nl for sending me this Votol controller. If he had not have done that, I have to readily say that my expectation for Chinese stuff is not very high, and so I probably would not have chosen this as something to do a teardown on. I just didn't have any expectation to be very good. But as it turns out, I am pleasantly surprised and pleased because this is actually pretty good. So there is one detail about, or two details about the outside that I don't much care for. So this little plastic piece goes over here, and then you have a couple of sheet metal screws that just thread into plastic. I'd like to see brass inserts there, because otherwise that's going to strip out after a while. And then the other thing is right here you've got some screw holes that go through the aluminum, and then screws, more of those same sheet metal screws basically, they thread into the plastic. If you look at, like, say, a Far Driver, an EBMX, a KO Moto, all of those, the plastic has a flange on it, and the screws go through that flange and then thread into the aluminum. And this does the other thing. The screws go through the aluminum and thread into the plastic, which is less secure. Would definitely like to see that change. It's a minor detail, I get it, and it's really not going anywhere because it's all, like secured down with silicone. But still, I would very much like to see that change and thread into the aluminum and not into the plastic. However, this plastic is fairly impressive stuff. And so let's start looking inside. So as you can see right up at the top, it says Votol, it says EM-150, and right below it, it tells you the kind of plastic. So PBT plus GF30. This is a specific chemistry from a company called Ensinger. GF30 indicates glass-filled 30%. So this is glass-reinforced plastic, okay, which makes it very tough. And PBT is specifically polyester. And this is their branding for that, this Ensinger company. So glass-filled polyester is the same stuff that is in my DeWalt drill. Yeah, glass-filled polyester. I mean, this is tough stuff, right? And here it is in the lid for a motor controller. I don't know what Far Driver does. I haven't, cracked a cover to see if there's anything like this. But, when you don't see any label like that, there's a pretty good chance, like 100% chance, that it's ABS. And that's the case for KO Moto and for EBMX. It's ABS. And this is much stiffer, much tougher stuff. I am fairly certain that this tough piece of plastic, I'm not going to actually try it, but if you took this and you drove over it with your car, probably nothing would happen because this plastic is really tough. So yeah, it's got a lot of tensile strength to it. It's very heat resistant. Yeah, everything about about glass reinforced polyester is pretty awesome stuff. Anyway, yeah, I'm probably going on a little bit too far about that silly cover, but it's a really good cover. And Votol could have cheaped on this one, and they didn't. These right here, those had silicone caulk around them, and then they were stuck down to the gasket that's on all the connectors, so that was all very nicely sealed. There was silicone caulk in this groove right here, and also inside here. So when those two things were mated together, they sealed up quite nicely. These grommets right here, they were not silicone to the plastic. I changed that and added it myself. So if you can see the shiny stuff around there, that's because I did it. Otherwise, they were just, fit in place. So I would have liked to have seen that be better. But Still, you know, it was probably plenty enough for like hosing off the controller or riding in the rain or something like that. Anyway, yeah, that cover is really impressive. Never expected to see glass-filled, 30% glass-filled polyester in a motor controller cover. All right, so inside, this is also pretty good. Right here is your main DC to DC for battery voltage down to 12. You've got a couple small linear regulators. You have an STM32F103 CPU on here. There are libraries for FOC control for this chip, but this is a sinusoidal controller. That was Votol's choice to do it that route. I don't know why they did or didn't, but yeah, you know, if you look at the documentation for the thing, there's no evidence that this is FOC, and also if you look in the setup app for it, there's no indication in there that it's FOC. And to lend more to that, here's the shunt, and that's on battery minus. There's nothing on the phases at all for measuring current. So the chances that this is field-oriented control is pretty low at that point, like non-existent. So anyway, yeah, it's not FOC. These MOSFETs, they were held down by three things. So that little silicone piece, one of these little bars went across it, and then 4 M4 screws. So the MOSFETs are really secure. And of course I wanted to pull the board up and I wanted to see what the MOSFETs were, so taking all that stuff off brought me with a pleasant surprise. And let me pull this board out of here. So it fits down in here very nice and snugly, even without screws on it. And there's got plenty of screws. So there's 2 screws here, plus the 4 on each side for the heat sinking, and 2 more down there. The board is not going anywhere on this heatsink. So when I took those bars off, I was pleasantly surprised by these MOSFETs. I was figuring, you know, they're just some Chinese brand of MOSFET, you know, Huawei's or GG's or something like that, and they are not. These are magnet chips, Western brand, and these are MDP 10 and 27s. When I pulled up a copper bar, or I mean a steel bar like this, and I saw that, and there's like, no way, this is one of my all-time favorite MOSFETs in TO220. I have used many of these MOSFETs. So yeah, to see this in a kind of a low-cost budget Chinese controller was astonishing, to say the least. I'm very happy to see that. Magnet Chip's a good brand. Good Western brand of MOSFET. Yeah. Good job, Votol. That's a heck of a lot better than I can say about some other folks. Alright, so the MOSFETs themselves, so there's 4 of them here, 4 of them here, and 4 of them there. That's for the high side of this phase. They are soldered down to a metal core printed circuit board. It's all 2 millimeters thick. This isn't a current path. This is a heat spreader, okay? That's how they're using it. And they're using solder to be the transfer medium for heat from the MOSFET into the heat spreader. So this is kind of clever. I like this. Current carrying here is negligible, if any. That's really all done through the MOSFET legs, and none up here. This is purely about getting heat out of the MOSFETs. It's a thermal path purely. And that gets it down to here, because now you have a much broader piece of material here to transfer heat away from the MOSFETs to the heatsink. So that's really good. I like that. I have not seen somebody do it just for that purpose before. Most of the time, the MCPCB is a current path and it's thermal. And this one here, no, they just said, no, we're just going to use it for thermal. That's it. All right, so right here, this is battery minus across those 2 sets of through holes. And the inside of the standoffs, you can see that little cutout in them, and that's milled out. You know, that's a machined part right there. And that is to allow you to bridge, yeah, you can see them. So right there's a bunch of circuit traces, and that's all of the gate control signals coming out of the CPU going to all the low side and all the high side MOSFETs. So they hid that in between there. This is all battery minus across here, but this is not your only way to get battery minus from this side here to this side here, you know, i.e. use that. There's more on the bottom side, which you'll see after a while. Okay, right here you have one large massive shunt. So if this controller can measure phase amps, it's not going to do it very well. It's going to have to make a lot of assumptions about phase amps. This is really about battery current and not really about phase current. So yeah, if you really want to do phase current sensing, you really need to do it at the phases, not like this with a battery minus shunt. However, this is not bad for here, and this is your battery minus bus, a big hunkin' piece of copper all the way across there. I'm just going to hazard a guess that this one piece of copper is more material than is in all of the reinforcing in like a KO Pro or an F-Spec power stage. Because this is 2.5 millimeters thick, and it's one big piece, and it's not like little sections and pieces and stuff kind of stuck down haphazardly. No, this is a custom-made part. You can see all those little cutouts in there. This is a piece that was made specifically to fit in this board to get current from battery minus to all the MOSFETs, and to do it very well. Alright, and battery plus is the same way. So here is battery plus, and again, one of these, get the glare off of there. This screws down like that with 4 M4 screws, and it's all really reinforced. Those through holes right there are reinforced on the bottom side. Lots of vias in all of that stuff, plus the copper that's on the bottom side. You'll see in a minute. And then you've got this little piece of copper right here. And then here is your main battery plus bus. And again, you know, a big chunk of copper. This is one piece is probably more copper than everything that's used for reinforcing an entire KO Pro or F-Spec controller. One thing I don't like about battery plus is this little gap. Why they didn't just make this an L, I don't know. But yeah, they should have. That would make this a little bit better. But still, yeah, that's still a big giant honking piece of copper, custom cut specifically for current carrying for the entire battery plus bus. Okay, what else do I want to show you? Yeah, two other things. So you can see all this componentry right here, and the same thing is true down here. They didn't use a gate driver IC for gate control. Instead, they did it with all discrete components. So there's a little MOSFET there, some small capacitors, things like that, rather than using a proper gate driver. Not my first choice, but yeah, if that's the worst thing about this thing, then that's really not a big problem. I like all these big capacitors. These are all 100 volt, 1000 microfarad caps, and two 470, 100 volt microfarad caps in the middle. So that's all your DC current, or DC ripple filtering rather. The high frequency stuff is kind of lacking in this controller. So you've got a little ceramic cap here, you've got one right there, you've got two of them right there, and there it is, one right there. And that's it. That's all of the high frequency filtering on here. And, well, it's not enough. They should have used bigger ceramic caps, and they should have used more of them. And so, yeah, those 5 are not really enough. It's inadequate. So I'm going to say that probably high frequency side, this is probably kind of noisy. As far as just DC bus, it's probably pretty nice and clean. Because there's plenty enough capacitance here in those 6, 7, 8 electrolytic caps to keep the DC bus pretty clean. You probably don't need more than this. Yeah, that's probably going to be enough of that. But the high frequency side, all the ceramic caps, meh. All right, let's flip this thing over. All right, so you can see these pieces of aluminum here, these metal core printed circuit boards that are acting only as a heat spreader. That's all they're doing. So that's pretty cool, and that creates a lot of surface area for the backside of those MOSFETs. And as a result, you don't need Kapton tape. You need some thermal paste between here and here, but that's it. Because this is acting as the electrical insulator for those banks of MOSFETs that are here. You know, through its ceramic front face on it. So it's doing a really good job of that. That's making a really good thermal path, and it's eliminating the need for Kapton or silicone pads or ceramic pads on the back of all the MOSFETs to electrically isolate them, because that's doing it right there through that ceramic piece. All right, this right here is, as you can see, there's a 2 millimeter thick piece of copper on there, and you can see the 4 through holes in it, and those thread right through that copper right to here. So it's a pretty solid current path, and they're using the screws as part of the current path to get to from here to the actual standoff. So that's really good. And you know, it's also got those large areas of surface on here that stick down to the circuit traces on the other side, which have lots of vias in them. So yeah, this is a pretty solid current path from the standoff to here. And like I said, that's battery minus. So here's the shunt. As you can see, here's the shunt. Oh, sorry for the glare on there. And yeah, this copper pad this copper reinforcing, it's touching that side of the shunt and they're soldered together. And the other side of the shunt right here is touching this piece of copper right here, and they're soldered together. So as far as current path is concerned, this is excellent. This is not a problem waiting to happen in any way. If that battery minus bus gets warm, I would be astonished. All right, so I mentioned one other thing about these. So you can see all those little pieces of copper that go down in this custom cut piece of copper specifically for this purpose. All right, so what they do is they bring battery minus right to the MOSFET legs. And so there's a little nubbin of copper sticking up right there, and it's soldered to the traces, and it is right at the MOSFET leg. So excellent current path from battery minus to the MOSFETs. And the same thing for the other side. So here's the positive side, that's battery plus bus right there, and you can see the same little pieces that go down. And on the bottom side, here's those little nubbins that go through right to the MOSFET leg. So battery plus and battery minus to the MOSFET legs couldn't be a whole lot better than this. This is pretty darn good. Right up there with, I don't know, if like the EBMX current paths are like a 10, this is like a 9.5 or a 9.7. Yeah, this is very good. And then, of course, the phase buses here, here, and here, same thing. This is very similar to like what Necular does. You can see those little nubbins that come out and come right up to the MOSFET legs. And so this is the high side, and this is the low side, and here's your copper bus for your 3 phases. And again, that's more 2mm copper, and it goes right up to the MOSFET leg. So this is all very low loss. Yeah, really good current pass here. Really good current pass. Votol, all I can say is good job. You guys did an excellent job. KO Moto, do this, and I won't have anything to complain about your your current pass sucking. Because if you do this, I'm going to do what I'm doing right here and say, this is really good. You should do this. This is really good, KO Moto. Copy Votol. They did it right, and you screwed up. Because this is awesome. Yeah. So as far as current carrying, attention to details, good current pass, low resistance, low losses, Votol has got a really good design. And I can say the same thing about, like, say, Necular's got a good one. So does Trampa. ASI is pretty good. Let's see, who else is also very good? EBMX is excellent. So yeah, this is a very good and excellent current path from battery plus to battery minus to all the phase buses. This is very good. Yeah, can't complain about this really in any way. All of my complaints all happen on the top side, and one of them is right there. Yeah, love magnet chip MOSFETs, but you can see that MOSFET leg right there. So they're using the full length of the leg, so they're building up a considerable amount of heat in the MOSFET leg, which just makes the MOSFETs hotter. And what they really should have done, since these are TO220 MOSFETs, is they should have used the fat section of the MOSFET leg and butted that right up to the board. So that would have shortened the leg length significantly, and it would have lowered the amount of current that has to pass through the leg, and it would have been doing it through the thick section, which is rated for 75 amps, unlike the skinny part, which is rated for 50 amps. So that would have been a lot better if they would have done that. With the MOSFETs, I love magnet chip MOSFETs. These are really good ones. I've used these many times, but how they soldered them in place is not so great. Don't like this little dinky amount of ceramic caps that are in here. That could be a lot better. And that's pretty much my biggest gripes about it, you know, as far as the board is concerned. Otherwise, this is a pretty solid design, folks. Anyway, yeah, Mike over at evperformance.nl, thank you for sending this to me. I am pleasantly surprised by the build quality here. This is pretty darn good. And as you can see, this is a lot of surface area screwed down to 2 large pads and reinforced on the backside by a boatload of copper. And that's true for all 5 of these. And they're screwed down with 4 M3 screws each. This isn't going anywhere. This is really good, really sound, solid build. Yeah, if you're looking for a kind of a budget controller that is going to be pretty good, buy a Votol. Yeah, buy a Votol. I would never have thought I would say that about a Chinese controller, but I am duly impressed by this.